Continuing on with our review for the Georgia milestone, today we are going to be talking about creating and graphing equations. And we talked about 3 different types of functions this year. We talked about linear functions, quadratic functions, and exponential functions. And I'm going to make sure to go through an example of each, as well as looking at some graphs in comparison. So the first type of function we're going to talk about is linear functions. And we started off with linear functions in slope-intercept form. And slope-intercept form is y equals mx plus b, where m is your slope and b is your y-intercept, while x is going to be your independent variable and y is the dependent variable. So knowing that each 4 of the variables in the slope-intercept form represent something different, it will help you when you're creating your equations. So this first problem says that 320 students went on a field trip to Washington, D.C. 5 buses were filled and 70 students traveled in cars. So write an equation to model the situation. So the 70 students that drove in cars are going to be independent, where the students on the bus are going to be the x variable. So we're going to say 320 students were taken by 5 buses plus 70 individual students. Once you have your equation, they ask how many students were in each bus. So they want you to solve for b. So we could say that 320 equals 5b plus 70, and I want to get b by itself. So we talked about solving equations in the first packet, so if you forgot about solving equations, you need to go back and watch that. So I'm going to subtract 70 from both sides, and I get 250 equals 5b. I still don't have b by itself. I need to divide each side by 5, and I get that 50 equals b, or there were 50 students on each bus. Once you create your equation, typically they're going to ask you to use that equation to solve for one of the variables. Number 22 is very similar. It says that Lynn is tracking the progress of her plant's growth. Today the plant is 5 centimeters high, so that's going to be your starting value. So today the plant is 5 centimeters high, and the plant grows 1.5 centimeters per day. Remember that your slope keywords were each, every, and per. Whenever you hear those words, you should be thinking about slope. So write a linear model that represents the height of the plant after d days. So we're going to say y equals 1.5d plus 5. So the plant grows 1.5 centimeters per day, and it's starting at 5 centimeters. So your y-intercept is always your starting value. Good. Then it asks, what will the height of the plant be after 20 days? We said that d represents days, so I'm going to plug in 20 for d. So I have y equals 1.5 times 20 plus 5. If I type that into my calculator, 1.5 times 20 plus 5, I get 35. So after 20 days, the plant will be 35 centimeters tall. The second part of this paper asks us to match each one of these equations to one of the graphs. So we have our first equation, y equals 5b plus, well actually, we have to get this equal to 0, or y. And this one is already given to us, 1.5d plus 5. Our slope, or our y-intercept is 5, so I'd be looking for one that has a y-intercept of 5 and a slope of 1.5. And that looks like this. Because our y-intercept is 5, and this is going all the way up to 100, you could see that this one, these two go together, and then these two go together. And this one could be determined because you have to get it equal to 0 in order to see where your y-intercept is. So you have 320 equals 5b plus 70. To get it equal to 0, you subtract 320 from both sides, and you would get y equals 5b minus 250. you can see that the y-intercept of this graph is negative 250, and it's going up 5 over 1, given your slope. Alright, in the next video, we'll talk about quadratic functions.